Hi everybody, welcome to Socsci10 Statistics Spring 2021 discussion number 9. Okay, so for the upcoming homework, you're going to need to know about the binomial distributions. Now, what is the binomial distribution? The binomial distribution is a distribution where you have two mutually exclusive possibilities of happening, right? You've got one possibility, we'll call that P. And then you've got another possibility, we'll call that Q. But the probability of Q happening is going to be 1 minus P, right? So it's the, you either get one or the other. You don't get both. So this is binomial. So the word bi means two. So basically there's two outcomes. And in the book, you're going to see it defined as in the probability is the number one over here. You're going to look at this formula in the book, and it's going to say it's the probability of an event happening, right? Now the way you look at this probability happening in a certain number of trials, right, is you got to look at what's the probability of it happening in one trial. Well, we're going to let that be pi, right? So that's the first variable here. The probability pi is the probability it happens in one trial. So, for example, if you're rolling a die, the probability of getting a certain number is going to be 1 out of 6. So if you're asking, if you're going to say, what's the probability of me rolling a 3 in one trial? Well, 1 out of one time in one trial, well, you can plug it in and you see that you will get 1/6 out of this equation. So you have the individual event probability, that's going to be pi. The probability of the event happening one time. And what you're saying is I'm going to do n number of trials. And in those trials, what's the probability that it happens x times in those trials, right? It's going to be given by this formula here. Another way you might see this formula, one might be a little easier to understand, is this alternative definition, which I found on Wikipedia. I don't know if you guys have started using Wikipedia yet for some of your mathematical learning, but Wikipedia is actually a great resource for mathematical learning, although sometimes it gets a little dense when you want things to be boiled down a little more simply for a class. But if you're really interested in the mathematical construction of the formulas and history or explanation, it is a really good resource. I recommend using it. So an alternative definition of this formula is the following, right? So the same thing, we've got the probability of something happening a certain number of times over a certain number of trials. Well, how are we going to calculate that? Well, you can see down here in this alternative definition, on the far right of the alternative definition, we have n choose k, right? Times p to the k times 1 minus p n minus k. Well, what are the alternative variables here? So instead of saying pi, we're going to say p. So p is the probability of something happening, just like pi was the probability of an event happening in the first one. Here we use p. And you can see we use 1 minus p instead of 1 minus pi, right? We use little n to represent the number of trials instead of big N. And k is the number of times we're looking for the event to be k, right? To show k. And you can see here, it's a little easier to understand because you've separated out the combinations, right, from the two distinct probabilities. And you might even see this labeled another way, where you'll see like the 1 minus p will be replaced just by q, and that's the probability of the other event. So if one event's p, the other event's q. But of course, these are mutually exclusive events, so q is really equal to 1 minus p, and so that's how you get these this alternative. So how do you get the mean? What's the mean of this? Well, it really depends on the number of trials you have. And the way you calculate that is the expected value, right, of the expectation of getting X number of something happening X times is really the number of trials times the probability of it happening once. Very easy. This is some easy stuff. And this is, you're going to need to look at, understand this binomial distribution and how to calculate the mean and variance and the probability of something happening for the homework. So I think this is all important to go over. Now the variance, of course, is n times p times 1 minus p, right? So it's the probability of it happening times the probability of the other thing happening times the number of trials that you've conducted. That is the variance in x, right, of the sampling distribution of x. So you're looking at, how many times, like what's the probability of getting x results and of n trials, something a probability of p in a binomial distribution. So there's an alternative probability of 1 minus p, right? There's two alternatives, p and the converse of p, or the inverse of p is 1 minus p. That's the so that's how you get the variance, right? And one of the examples they talked about in the book, by using this formula, the first formula, is this probability of getting 0 heads, which will be the top equation on the right, 1 head, which is the second equation on the right, or 2 heads when flipping 2 coins. So each one of these gives you the probability. So the probability of getting 0 heads is the same as the probability of getting 2 heads if you're flipping 2 coins, right? So we're flipping 2 coins in this example. And you can also use this equation for doing a cumulative sum when you're trying to calculate what is the probability of getting one plus another event probability. And they talk about that a little more in the book. But the main thing about the binomial distribution is you have alternatives. You've got a distribution that's represented by one choice or another. You're not looking at multiple choices, although you could, for example, let's say you had 5 choices, right? You had 5 choices, you could get 1 of 5 results. How could you model that with a binomial? Well, you could pick one that you wanted, right? And just say, well, I'm going to add up what the probabilities are of getting the other 4, and just say, if I'm looking at 1, with the probability of getting a number on a 6-sided die, it will be 1 out of 6. How can I represent that with a binomial? Well, then the probability of not getting that one number is 5 out of 6. It's the sum of all the probabilities of the other numbers, right? And then you can use the binomial formula to look at the probability of not getting a particular number or getting that number and not the other ones, using 1 minus p, right? It gives you 5 out of 6. And if you have, in the example of the die, if you have 6 dice, right, you can split them up however you want. Well, what's the probability of getting 2 or 3 x number of times in n trials, right? Well, probability of getting 2 is 1 out of 6. Probability of rolling a 3 is 1 out of 6 on a 6-sided die. The others together is 2 out of 6, right? 1 minus p, so you're dividing the probable outputs into 2 sets of outputs, and then summing the probabilities of getting each element in that set, right? And now you've turned a sampling problem where you're looking at multiple results into a sampling problem where you only have 2 results, but they're basically 2 groups. They're ORed together. So what's the probability of getting 2 or 3? It'd be 2 out of 6. And what's the probability of getting one of the other 4 numbers? That'll be 4 out of 6. And now you can use the binomial distribution to look at the probability of getting drawing a sample from one of these sets, x number of times in n trials. Okay, so hopefully that will be helpful in your homework. Binomial distribution is like the normal distribution. It's one of those distributions you run into all the time, and you can run into this sort of analysis where you have multiple variable outputs and you're combining them into 2 groups, 2 sets, mathematical sets, and then you can use the binomial distribution to do analysis on what the probability is of getting element from one set versus another. So binomial distribution, important to know. These equations are really easy to understand. One of the best ways to learn these equations is just to see the different forms that the equations can take and focus on what the equation is trying to describe rather than memorizing the actual characters that make up the equation. And here, if you're looking at the equation in the first bullet point, you can see that the first part of the equation is just to n choose k. And then you've got the same p and 1 minus p, except this time we're using pi. So it's just different flavors of writing the same equation. And once you really understand what the equation represents by practicing with the homework, which you should always do, then you'll recognize seeing it in different flavors and different forms, such as these. And well, good luck on the homework. It's due tomorrow night, and I'll see you guys next week.